Okay, John, whenever you're ready.
Harold, you were born in 1917, grew up in the 20s, and went off to MIT in 1934. These were fairly tumultuous times because you were probably old enough to remember the Depression, and the Depression was well underway when you went off to MIT. Were these things impacting your decisions about going to school and where you were going to go to school, or were you more or less not oblivious, but not severely aware of these kind of things at that stage of the game?
Well, I would say that the impact of those times were to put a severe economic constraint on what your thinking was. I mean, it was clear to me that I really had to study and get good marks in school so that I could get a scholarship to go to college, because my parents didn't have the money to send me to college, and I had to get some financial assistance somehow. So yeah, I would say the Depression was quite a factor in influencing my thinking. But in terms of a specific college, or whether it be MIT or someplace else, that really was a decision that was made, I would say, in August of the year that I went to MIT in September. As a matter of fact, it was somewhat contingent on my getting a scholarship. I got a scholarship to MIT, so I went to MIT. It wasn't part of a long-range plan other than this overall environment which says you better be smart, because you're going to need all the wits that you can muster.
When you got, at the time you got to MIT, that institution was sort of coming into its glory years, you might say. Were you aware that you were, stepping into an institute that would maybe be one of the bywords for engineering in the 20th century in this country?
No. As a matter of fact, one of the factors that influenced me to go to MIT was my friends who had been part of a debating team that I was on in high school. And in the previous 2 years, the people who were members of that debating team went to MIT. And I frankly didn't even understand where MIT was located. I thought it was a Western Massachusetts college like Amherst or Williams. I mean, I was quite ignorant, to tell the truth. Oh. So there was no thought that MIT was the best, and I therefore ought to go there.
You went there specifically, I guess, to do engineering. Your father was a civil engineer. Did that have any influence on you, your father's occupation?
Yeah, I had the feeling that Dad would have been a good engineer. In fact, he was a good engineer. And largely he got out of engineering because the family that he married into had a business, a family business, and he ended up by working in that business. Well, the way he went about doing things was in a systematic fashion of a civil engineer. I can remember outlining a garden plot where we would plant vegetables and so on. I worked with him on that. So, and he continually referred to engineering, but it was by no means a hard constraint. I would say that the influence that he gave me to essentially choose what I wanted to do with my life, I think, was a big gift. I mean, he was the head of the small wholesale candy business that he ran, and the normal thing would be, well, you're my son, now you better take over the business. Well, he felt that he had been brought into that business by mistake, in a way, and he didn't want me to feel that I had to stay in it too. So to that extent, he was a very liberating influence of, it's my life and I can do what I want with it.
Yeah, that's impressive that he had that kind of foresight. So now you're at MIT, and there's an institution that has a lot of famous names associated with it, some of whom were teaching at that time, Norbert Wiener and Gilliman and those people. Were these the people that really influenced you there, or was it just the general level of quality of the place that really had the big impact on the education you got at MIT?
Well, first of all, I didn't go to MIT to be an electrical engineer or a control engineer. I thought I would be a chemical engineer. And in the first year, I got a prize as being an outstanding student in chemistry. But it turned out that I had spent most of my summers on Lake George or camping in the mountains, building trails, and the stench of the chemical lab just wiped me out. So after 3 or 4 months as being enrolled as a chemical engineer, I crossed that out and said I'd be an electrical engineer. So I really wasn't influenced by the quality of the teaching so much as just the general environment there. Of course, the other thing that happened was I became a co-op student during my sophomore year. So the first year was essentially devoted to being a chem engineer, which I gave up. So I then became a co-op student, and it was, I would say, the experience of working in GE, which I did at the end of our sophomore year, that started me in the direction of engineering and electrical engineering.
What do you think of the co-op experience? Do you think it makes better engineers if these students spend time out in practice, if they integrate that into an education, or would they be better served by just going straight through?
I'm a believer in co-op education. I think it's terrific. As I mentioned, I was short of money, and working, getting an income as I went along, that was a big help to my mental frame of mind. But over and above that, just the understanding of the fact that there's a lot more to engineering than the equations and the theory of engineering. I mean, the fact that you had to make out your time card each week, there's a certain amount of just routine that you have to go through. And the other thing is that there are a lot of people doing interesting things, and you had a chance to look over their shoulder and see what were they happy about and what were they slowed down with. So I think that the co-op experience was excellent for me.
Yeah. It would seem to me that if you're out there working, you see some of the pressures that impact engineers. And one, that you have to get a product to market, you have to get something done. The iterative part of the engineering process of trying to make it work, having to go back, get a better model, whatever, to pass over it again, which maybe is sort of missing sometimes in the purely academic environment. What do you think about that?
Well, I feel very sympathetic to what you're talking about. Also, you get to realize the difference in time between, say, research and development and engineering and manufacturing. In other words, there's a cycle involved there that may take years, and you really have to be prepared with a product that's reliable and its cost attractive and so on. So that I think that there's a lot more to the bringing of an appliance or a product to the marketplace that you learn as you're a part of that system.
Mm-hmm. So you stayed on at MIT to do your master's degree. Did you do a thesis there for part of your master's?
Yes, I did. The one thing as a result of this co-op experience, we didn't get a bachelor's degree at the end of 4 years, but we got a combined bachelor's master's degree at the end of 5 years. And during that time, we had worked part-time. We had like three semesters, a fall, spring, and a summer one, and we would either be working or taking courses then. One other thing which came out of that co-op experience was that in addition to the 40 hours of work, we had to take certain classes, certain courses. So the idea of working nights on one project and working days on something else was something I got used to fairly early. It turned out my father had been in business, this candy business that I mentioned, and as a result, he got involved in a lot of legal questions. So as I was growing up, I have a picture of him at night working on this law course that he took, a correspondence course. But the idea of that you may have more than one job at a time was something I learned pretty early. And we had that, I mean, during these 5 years that I was on the co-op course, like 3 of the years, I was taking some classes at night and working during the day. So the idea of using your time effectively was something that I learned early on.
Do you have brothers and sisters who...
I have a sister who was 4 years younger than I was, and she was just sufficiently different in age that we seldom did very much together.
Okay. So, you finished at MIT. World War II is just about to start, I guess. It's officially started in Europe. It's not started for us, I guess, until a little bit later. But you chose to go back to Schenectady, where you grew up, and go to work for General Electric. Did you have any thoughts about working at the radiation laboratory at MIT, or was... I had to make that decision before the radiation lab was in being, I think. Was that right?
By the way, you asked me about, did I do a thesis?
Yeah.
And I didn't answer your question. I did do a thesis, and it was on power system stability. Actually, the whole idea of stability was something I really hadn't thought about quite in those terms initially. But I remember I was a part of an honors group at MIT in my junior year, and one of the tests of that honors group was an oral test, and they asked me a question about the stability of an aircraft on the ground, and you had 5 minutes to answer it. I didn't have the foggiest notion of what stability was. And those 5 minutes were just sadness in my life because here I was supposed to be able to answer a question I didn't even understand it. But at any event, I did get exposed to the idea of stability. And as a matter of fact, I did do a thesis on the subject of power system stability. And the whole idea of hunting and oscillating was a part of that thesis effort. And as a matter of fact, when I went to, part of the reason for going to GE was they had people like Crary and Concordia and Krohn who were working on power system stability. And as a matter of fact, one of my early test assignments was to work with those fellows, which was a tremendous opportunity as far as I was concerned.
If you worked for General Electric 43 years,
Right.
And if I look back at your papers, I see you associated with any number of different laboratories within General Electric. So, were you moving constantly from laboratory to laboratory, or was there some other force at work here?
Well, in business, there seems to be a habit of reorganizing things every 3 or 4 or 5 years, and to a certain extent, my efforts were in one area, namely control systems, and the name of the labs or the organizations kept changing around what I was doing, but what I was doing was pretty much the same thing, but in many cases with different organizations. Like, for example, I worked with large steam turbines with the turbine controls, worked with locomotive department. They were involved in subway trains, worked with people in jet engines who were working in the propulsion systems. So I did have a fair amount of exposure with different organizations. As a matter of fact, one of the assignments I had, which was very interesting, was in connection with the Apollo moonshot. And GE had the responsibility of the reliability a portion to Apollo, and I can remember with a great deal of pleasure going down to Florida and looking at the beach there at Daytona, and I enjoyed swimming, and I'd go down there and after work, and I'd look at the moon, and I'd say, coming out of the water, I'd say, geez, you think we'll ever get there? And although the names of the labs changed and the names of the people that we were working with changed, nevertheless, this common theme of control systems and systems in general with a high emphasis on reliability, that was a continuing thought.
Yeah, what were you working on specifically during the war? You remember?
Yes, I started out, as the war began, I was a part of the GE test program, and I was selected to take this advanced engineering course, and later became a supervisor of the electrical part of that. So to begin with, during the war, I was on test. We tested motors for submarines, it tested searchlights, it tested a whole flock of things. Then I got involved in the Navy part of things, and that involved working on things like remote indicators, like Selson's control transformers and so on. And I had, in my thesis, studied these large power generation equipment, hundreds of megawatts sort of thing. And the problem I had to do was to look at these little control transformers and find out what are some of the causes for inaccuracy. So there was that activity. Then I got involved in a torpedo director, and towards the end of the war, I got heavily engaged in the Mark 56, which was a gunfire control system for the Navy. So I had a lot of different assignments, and following the war, I still continued on in the military work, but then I got involved in aircraft problems.
Yeah. So I guess for a lot of people, it seems like World War II was the motivation for the growth of the civil mechanism idea, gunfire control, and some of these other things. Do you think that war really had that kind of influence, or would these things have come along anyway? At maybe roughly the same rate of progress?
Well, probably not. I mean, I think that the amount of effort that went into control systems work during the war was probably far out of proportion to what, say, industrial companies like General Electric would have done, left to their own devices. Prior to World War II, there was a fair amount of work going on in industrial control, like for steel mills or paper mills or other manufacturing processes. But even after the war, the industrial people were reluctant to spend the time for R&D that the military allowed people to do during the war. So I think there was a lot of progress made, but that was largely because the government felt that it was important that we improve our knowledge and performance. Mm. And so the government spent the money. Now, it just hasn't been that easy to get government money to be put into industrial research. So I think without question there was a very large growth of control systems activity that was fostered by the military in World War II.
Yeah, there's an implication there that industry in general doesn't want to spend enough money on research. And yet, I can remember when I was a kid in the 50s, the General Electric theory during the slogan, "Progress is our most important product." How was the environment for engineers working at GE in the late 40s, early 50s, when we came out of the war into that post-war boom? Was that company really believing in that slogan, "Progress is our most important product"? Were they putting real effort into the research end of the business, or were they still product committed? It's hard to see how they'd balance something like that, but it'd be interesting to me to know.
Well, I think the slogan, "Progress is our most important product," I think was pretty much believed by people in doing development and research work. Actually, of course, GE's research lab at that time may have had like 300 people. Now they have probably over 2,100, 2,500. So, I mean, it's a much bigger outfit. And in those days, in the days I'm talking about, in the late 40s and 50s, there was a great deal of effort on the materials end of things. I mean, we made artificial diamonds, we made silicones, and a whole bunch of new materials were brought into being. A lot of the big motors and generators had new types of insulation on them, so that they were mostly focusing on what I would think of as materials, as opposed, if you think of the world being composed of energy, materials, and information, they were mostly focused in on the materials end of things. On the other hand, these advanced development labs they invented things like the amplidyne and other power actuators. And I would say that not only that, GE got into the major appliance businesses, automatic washing machines, dryers, dishwashers, and so on. So there was just an awful lot of things to be done, and it was a time of very dynamic growth.
So as GE's grew over the years and got bigger and bigger, did they get more compartmentalized? Was there probably a tendency to get rid of the cross-disciplinary efforts to some extent?
Yeah, there was a realization on the part of management that they had to decentralize, and starting in the early 50s, these different, we separated out the appliances from the jet engines, from the steam turbines, and so on, so that this business of decentralization, restructuring that the Russians are going through, we went through that, a long time ago.
You look upon that as a necessary thing that they had to do?
Yeah, they really did. I mean, because, if you're competing against General Motors and building diesel engines for railway cars, you can't be loaded down with a bunch of decisions that have to be made with regard to dishwashers. So the idea of decentralization is really, I think, was a necessary move and a desirable one. But I mean, you're talking about a business of, say, $500 million, which was GE, say, before World War II, to $50 billion now. I mean, how many balls can you keep up in the air at one time?
It's a stage that GE is at now. Of course, you're looking back on it, but do you think that they've got the right formula for success here as far as competing in world markets?
Well, like anything else, you have to ask yourself, well, what do you mean by success? They are probably spending less money on inventing another Maxwell's set of equations or Newton's laws. On the other hand, they are exploring a whole other way of measuring success. I mean, Jack Welch has said that for GE to compete in the world market, they have to be leaders. And so if they're number one or number two in a particular area of activity, well, that's part of his measure of success. And another measure of success is what's happening to the price of the stock. And as certainly the current management has a different set of criteria, I would say, than the old ones. But on the other hand, when you're dealing with very volatile markets, like, for instance, the energy market, in 1972, GE had a backlog of like $10 or $12 billion of steam turbines. I think in the next 3 years, they hardly got another order, and in the next 10 years, they got no orders for steam turbines. Now, how can you stay in business for a 10-year period if you aren't getting any new orders. So in other words, just in terms of survival, a different criteria for what is success has come into being. And on the other hand, I think that GE has been willing to invest more money into R&D. They haven't really cut back on that significantly. And as a matter of fact, my impression is that the R&D effort is continuing, in fact, increasing as time goes on. We're solving different problems. But certainly the world out there is certainly a different one.
There's some concern, I guess, that financially and in terms of the way our government's organized, we're not structured to have the kind of leverage financially we need to do some of these big projects. That maybe there has to be some reorganization there, that even a company as big as GE can't compete with, say, corporation Japan effectively. What do you think about that?
Well, I think we certainly have to to look at these problems as they come along. And my feeling is that the government support in a number of new ventures is certainly well worthwhile. I remember a couple of specific instances where major GE company, major U.S. companies essentially bet the business in order to come up with a new product. I mean, the 747 case of Boeing is an example.
IBM 360.
In the IBM 360. I mean, these cost, from $3 to $5 to $10 billion, and companies just don't make that much profit in a period of time, in a reasonable period of time. They've got to have some a form of investment. I mean, the trick is to figure out, what activities are worthwhile to have this outside support. And it isn't always clear. And my impression is that Japan hasn't necessarily worked out the solution in a completely satisfactory fashion either. I mean, they talked about the 5th generation computer. I haven't seen anybody selling them or anybody buying them at the moment,
Let me shift gears here a little bit. And if you look through Harold Chestnut's papers, you see the early papers are on self-synchronous motors and applications of Bode's identification techniques and the like, what I would call sort of precise control systems kind of business. And then if you look, there's this steady progression to more and more general systems, economic systems, inventory systems, and then as you've gone along, even to the point of looking at sociological systems and world models of how we function as an international society. Would you like to comment a little bit on what sort of motivated you to move in that direction, away from what they call hard systems towards what they call soft systems, or maybe even some people would call it operations research?
Well, as we have been developing, the world is changing out there, and I was fortunate to get involved with this the startup of the International Federation of Automatic Control in the late 50s, and I was delighted to be the first president of that in the period 57-59. And having essentially put in a couple of years and more than that in terms of looking at what goes on in different countries, you ask yourself, well, what do you do for an encore? And the thought occurred to me was that the field of automatic control was moving along in good shape. We had established contact with all the other major actors in the automatic control scene, and so I began to look at, what are these controls being used for, and what likely areas should we be thinking about in the future. And so, the power systems, for example, you realize that's part of an overall energy system. And the steel mills are part of a material system, and so on, so that I began to look at what are these major undertakings that take place in the country. And I came up with these 7 sectors. I mean, first of all, if you're trying to describe a country, you need to know the population. I was 6 years old. I was burned out. And
that happened to me in baseball, same thing.
But I concluded either I was going to quit or else I was going to be.
Okay, John.
Harold, I want to shift gears a little bit here, and when you look at your papers, you see Harold Chestnut moving from papers on self-synchronous motors and Nyquist's approach, the Bodie approach to identification of models, towards more and more general, larger systems problems, inventory systems, modeling of business cycles, this kind of stuff. Was this a natural progression for you? Were you aware of it, or what in general led you to take this path instead of staying what they sometimes call hard systems or the control end of the business?
Well, I think there were 2 things involved there. One is there were an increasing number of people who knew how to handle the hard systems, as it were. I think of these systems, you call them hard, I would call them well-defined systems. Yeah. In other words, if you can write a set of equations that describe what the process is all about, that's one thing. But an awful lot of the work is involved with systems that you can't write all the equations, that there's a fair amount of uncertainty. So I tend to focus in on what I call poorly defined problems. And part of this transition took place because as president of the International Federation of Automatic Control, I made an effort to visit a number of different countries that were members, national member organizations of IFAC. And I would visit some country like, we'll say, Bulgaria or Norway, and I'd talk to the governmental people there, I'd talk to the people who were in industry there, and I realized that these governmental people had similar problems to what we had in General Electric. And so at any event, I had my eyes open to a much broader set of concerns, shall we say. So the fact was that there were other people who were handling the well-defined problems. I got more involved in the poorly defined ones. One other thing, and that is during that period, I started to work more closely with the corporate planning for GE. And they had problems of, should they put money into building better refrigerators, or should they put money into better jet engines? And their criteria frequently was not, how well any particular device worked, but what would this mean to the growth of the company? And the company really, in many cases, wasn't all that different from another nation. If you looked at the GNP, for instance, for General Motors in Norway, you'd find probably General Motors is bigger than Norway. So that the idea that their governments, decision makers have to get advice from somebody, and frequently that advice had to be technical. So there was a gradual transition that took place in my way of looking at things.
Yeah, I would guess from looking at back at those papers that given a choice between analyzing a well-defined system and modeling an ill-defined system, you much prefer the modeling and simulation business, and that probably you view that as a more interesting problem.
Yeah, as a matter of fact, in connection with these several laboratories that I was a part of, frequently we had to compete with other labs, and one of the decision criteria that we used. Was this a well-defined problem? If so, somebody else was going to work on it. If it was a poorly defined problem, it was something that I was going to be working on. And that's right. And as a matter of fact, the whole business of modeling these different systems, like for example, take the business of going to the moon. We had to test all this equipment, or somebody had to test it as components, and then how could you infer from tests of that sort whether or not the mission was going to be carried off successfully? So the whole business of modeling reliability was something we got into early on. So all in all, there were just all sorts of opportunities to study these poorly defined problems.
Yeah. You were sort of a pioneer in the whole business of simulation because you were there when computers came on into being as analysis tools and stopped being sort of curiosities in university. In fact, in the 1960s, I guess you wrote a number of papers talking about this whole business of simulation and optimization. And if you look at those papers, it appears that you were foreshadowing a lot of this business now of expert systems, neural networks, because you talk in terms of the interaction between the engineer and these simulation packages that he's using, and in effect the engineer is becoming an expert system in his own right. Do you feel comfortable with what's happened now with this expert system business, or do you think engineers could probably do it better than these programs that they come up with at this stage of the game?
Well, my feeling is that the best experts are people. And on the other hand, once people understand the system, they become sufficiently expert that they can, in fact, turn it over to an expert system, you can achieve some highly desirable results. A friend of mine, Joe Mundy, came up with a scheme for analyzing these little light bulb elements. But in any event, this replaced a whole bunch of women who used to look at these coils of wire as they just went by. But in any event, I think that there's a place for automated expert systems, and on the other hand, if you look at some of the political decisions that go on in the world, I mean, those I think are going to continue to be made by people. And so I think that there's a need for both sorts of expert systems. And I will have to admit that in terms of getting funding and support for it, calling something an expert system seems to be a little more successful than just telling somebody you need to know more information.
Yeah. You think that the modeling versus the analysis perspective is what has sort of caused this division or divergence between the systems people and the control people? Because it would seem to me that the systems people are more interested in these ill-defined, poorly defined problems that are large scale, whereas the control has gravitated towards, a well-defined mathematical model about which you can say more and more. I don't know, that's the way it appears to me.
Well, I've pondered on this matter of why there is a control society and a systems man and cybernetics society. In fact, I participate in both of them, and I see a need for both of them. I think to a certain extent the control people have been more influenced by the military in the sense that there are certain specifications or requirements of performance that are needed. On the other hand, the need for tackling new problems is certainly something that is tied up with poorly defined conditions. Like, for example, right now, it seemed to me that we're in a case on a worldwide basis where a whole bunch of people, nations, or what have you, ethnic groups, are trying to form their own nation or country. On the other hand, they've got to provide food and energy and materials and so on. And it seemed to me this is an ideal opportunity for a systematic look at what can be done to make life better for people around the world. And so I think we have an opportunity currently for an increased systems effort. And I don't know too much about what the needs or the demands in the control side, but I sort of sense a trend of moving people from control to simulating factories and so on, which are more systems oriented in my way of thinking.
Yeah, you see even within the control society now an interest in discrete event systems and some problems that have been skirted, I guess, for a couple of decades.
Parenthetically, that discrete event business, that was a technique that we use in connection with studying the reliability of Apollo. I mean, you've got the last 300 minutes of that countdown. Basically, we made simulations to make sure that everything that was supposed to happen for a good flight was in fact happening. And that was an interesting time where you had a combination of discrete events as well as continuous simulation. I don't know where that business stands right now, but I do know to a certain extent the work that I've been getting into in connection with global modeling, they have a bunch of discrete event activities taking place. So some of the techniques are applicable in both the control as well as the systems areas.
In the 60s, Jay Forster wrote that sequence of books, Industrial Dynamics, Urban Dynamics, World Dynamics, and he was putting forth the idea that the way to solve these problems, I guess, was to build a very accurate simulation and then let the people who were going to manage these big systems play with it, put different inputs into it, and see how the thing reacted, and in a sense, turn the manager of a factory into an expert system on what his system could do. What do you think about that whole approach? I mean, Forster is not as prominent now, I guess, as he was 15, 20 years ago, maybe by his own choice, but...
Well, I was a believer in Jay's methods, and unfortunately, that wasn't exactly the reaction of many economists, and it seemed to me that blew up quite a controversy, and I think what Forrester tried to do with those models was a desirable thing to do. And, it's like an experiment. He tried it, and it was successful to a limited extent. I think a great concern about the environment and also whether the raw materials would be available long enough into the future. I think he shed some very useful results. But on the other hand, it really built up a terrific resentment, as I understood it, with the economists and the people who were making the economic decisions. But I think in the long run that what he did was a necessary and desirable thing to do. But in the long run, the work that he did, that by itself, I think is not enough. Because in reality, our world has a whole bunch of competing elements taking place, and what's good for one group of people may not be good for another. And the idea of being able to forecast the future, if you will, in an economic sense, I think this is a pretty risky business. In other words, it's a useful tool, but it's going to take more of gamesmanship, and I think Larry Ho is trying to get some of that into his work of study of games. But unfortunately, at the moment, I don't exactly know where Forrester's work stands.
Yeah, it seems in the 80s he embarked upon this very elaborate model of the economy. And I remember he was at Michigan State in 1980 talking about that, but I never have seen any great impact from that.
Well, the thing that foils that detailed model approach is this gamesmanship. In other words, how would you be able to forecast the fact that the Arabs decided that they would change the price of oil through OPEC in 1972? Yeah. And that was a jolt that after which, whatever the assumptions were prior to that OPEC decision, they just were different afterwards. And I don't think, for people who want to be sure and have everything well defined, dealing with economic systems is not the business to be in.
And this may have been the implicit complaint of the economists in the first place, probably,
yeah.
To this approach. Still, for a factory that has sort of less of that sort of impact, it would seem to me that this approach was really the forerunner of what we're doing now in terms of, we're legitimizing this thing as an expert system now, but in fact what Forrester was saying is turn the factory manager into more or less an expert system. So he's got intuition about how to make this thing run.
Yeah. I would say, at the business level, I think the models are being used quite extensively. And, the whole business of updating the models and taking into account new situations. It seems to me that's what the business part of a newspaper is every day. They say what's new and different, and why do you have to change, or why do you have to be alert to the current conditions? So I would say actually that economic modeling is being used quite extensively. And I'd say that, it's one of those things. If you do a good job in business, you don't bother to tell everybody how you do it. And so the mere fact that people aren't talking about it doesn't necessarily mean that it isn't taking place.
In fact, you prefer not to talk about it, probably.
Probably so.
You've been involved and witnessed and participated in the evolution of any number of these professional societies, which in and of themselves are systems, I guess, in some sense. Mm-hmm. And in particular, you lived through this merger of the IRE and the IEE, I guess, into
the IEE
into mm-hmm. into what we now call the Institute of Electrical Engineers. Was that a move or a merger that had to be, or were there political connections or problems there that caused that to happen?
Well,
I've always been curious about that since I wasn't there when it happened.
Well, I was on the outskirts of it while it was happening. And as a matter of fact, I was president of the IEEE in 1973, which was like 10 years after the merger took place. And one of the articles that I had written was 10 years after the merger, do you still think it was a good idea? And I think practically everybody agreed that it was a good idea that it took place. On the other hand, that merger had been proposed for maybe 20 years. It wasn't the first time that somebody suggested, why don't the power engineers and the communications or electronics people get together? But it was ultimately, I think it was a matter of personality. And there was a trend which took place during that, I said 20 years. For 20 years, people have been trying, and it was probably more, were trying to make that merger happen. And the fact of the matter is that during that period of time, there was a cohort of students taking these courses. And the trend at the beginning of, in the 20s and so on, the stability of big electric power systems was really fascinating material. By 1950, there weren't very many people taking power systems economics, or power system stability. There, more and more people were working on radio or TV or computers or what have you. So the whole swing of what electrical engineering had changed from the AIEE emphasis to the IRE one. And the leaders in those groups, fortunately, were of a mind to recognize what was happening and said, hey, we'll be a lot better off if we work together. Even though we have a certain amount of overlap, we're much better off if we work together. And people like Ernst Weber and Clarence Linder, and there were a whole number of other guys who had been president of one society and sometimes president of another. And the upshot of it was they figured out a way of combining the benefits of merger and overlooking some of the shortcomings which would have continued if the two organizations had separated. I think as a result, the IEEE's position in the world is just an awful lot stronger than it would have been if they hadn't merged.
So we have the IEEE now, which is really a member-oriented organization in some sense. And now you're also involved in the creation of the next tier of the hierarchy, the A squared, C squared, and the IFAC. How does this fit together? How does an A squared, C squared, and an IFAC impact an outfit like the IEEE?
Well, it's interesting you asked that question, and probably if you ask the next several people who you interview, you'll find different answers. But the fact of the matter is we had two types of economic systems in operation, or political systems. We had the West with individual being able to make up their own mind whether they chose to join a technical society or not. And this was conducive to the IEEE's approach, namely, we'll have a membership organization, a membership of individuals. Now, the IFAC approach, we were dealing with nations. The IFAC organization, this International Federation of Automatic Control, is composed of national member organizations. So whereas the IEEE has like 300,000 members, IFAC has like 40 members. But this, from the point of view of the totalitarian countries or the socialist countries, this was desirable because the leaders of those countries wanted to have an influence on who represented them in these national member organizations. So as far as they were concerned, national member organizations was the way to go. And so we've got the best of both worlds in the sense that we've got the IEEE that says you can have any number of members, and I think the IEEE now is maybe 10 or 12,000 members in the Control Systems Society, and in the systems area I think there's probably 4,000 or 5,000. So any individual that has the money and the interest and the background can participate as an individual, but also the same individual can also participate through the national member organization, which in the case of the United States is A squared, C squared, which in turn is made up of representatives from the electrical, mechanical, chemical, and so on, steel engineers. And so the fact is that it's interesting as a participant in these activities to see what's possible under IFAC and what's possible under the IEEE.
Is IFAC a mechanism by which nations can cooperate on this reorganization in Eastern Europe now? Is that going to be one vehicle by which that happens? I'm kind of interested to see what you think about that situation there.
Well, I'll be in a better position to tell you that in a few months than I am right now. But I think this is what's happening in Western Europe and in fact, or Eastern Europe. Well, as a matter of fact, in Western Europe too, because they've got this economic community in '92 that's in the background and churning along. So something new and different is going to be handled in Western Europe, but also in Eastern Europe. Like, for example, as we see now, there are times when there are food shortages in certain locales. Is there something that, for instance, IFAC, I think we have a working group on agriculture or food. And is that something that working group ought to be working with the Eastern Bloc countries to improve the availability of food? Because I have a feeling that things could be done better than they are. And so the fact of the matter is, whether IFAC chooses to devote its efforts and focus some attention in terms of taking a systems look at these various countries is really a question of whether the upcoming management of IFAC chooses to do it, and also whether the national member organizations are willing to participate. And it's going to take, well, the opportunity is there and the need is there. And as a matter of fact, part of what I have been working on since I retired from GE is an organization which is called SWIS, which stands for Supplemental Ways for Improving International Stability. You'll see this theme of stability has gone through my life.
Yes.
Because it's pretty critical. But in any event, what I've been trying to do is to see what sort of an adaptive control system could we visualize and could be put into practice that would improve the stability between nations in the world. In other words, I think one of the underlying threats to society, to civilization as we have it right now, is the possibility of a major war, or war between major powers. Granted that to a first approximation, it looks as though things are more stable, and that it's less likely that we will have a major World War III. But it's by no means certain. And this business of instability is something that you really have to work on. I mean, in other words, we build control systems to accomplish a certain result. But one of the first things we ask ourselves is this system stable? And in the case of what's going on in the world with these 160 nations and so on, is we don't have much of a stabilizing activity. And I think that sort of an activity of providing stabilizing influences between countries is highly necessary. And as a matter of fact, the United Nations Secretariat in the past couple of years has established an organization which they call the Office for Research and Collection of Information, ORCI. And basically, to my way of thinking, that is a potential stabilizing mechanism to reduce the likelihood of international war or World War III.
Yeah.
Stop. You have to change things.
But unfortunately, this ORCI